Hi everyone, again welcome to this session of the LPS. Today probably will be the last lecture. We have covered so many things over the last several weeks. Started with looking at the Linux, then went into programming. We started with Perl, we covered Tcl, then we also covered Python. And today we are going to talk about Makefiles. Makefiles are one of the key utilities for the running a program automatically. The reason why we use Makefiles is because we want to capture the dependencies and essentially like use the dependencies to do certain things as well as not do certain things. So in a serial processing of files, basically, if you are doing something to one file and then you are doing something else, and if there is an error occurring at one point, maybe you need to back out to some place before you can continue. At the same time, if you find some error and then you have done some already like few processing steps, you don't want to go back all the way to the beginning and then do the processing all over again. You want to capture from the middle wherever it is successful. From that point onwards you want to move forward. And for these kind of things, a Makefile is used, where you can capture the dependencies in a serial fashion basically, and then you can use that to your advantage in terms of what needs to be run and what does not need to be run. So a Makefile is providing a way for a separate compilation, describe dependencies among the project files, and then that is the make utility, and use the make utility to do the compilation. So in a typical process for compilation, you will have like many number of programs like .c, and they will probably share a common header file or the h common.h. And then now so this is basically in a typical C environment, so you have multiple stuff, and then basically like they are assembled basically, and then from the assembler you generate the .o or the executable, which essentially like now you can link it and then you can run the program. So now if you want to change the C, but you don't, the green.c but not the blue.c, you don't want to compile the blue.c again, so you only want to compile the green.c. So a Makefile, once you specify how they are dependent, it looks at the timestamp and it looks at what changed, and if nothing has changed then it won't touch the particular file. So let's look at that. So using the Makefile basically like so Makefile or Makefile uppercase M, carefully look at that. Those are the standard ones. Even you can do other files also. And to run the make, it basically simply the make is the command name, and then you can say like make -s file name if the name of the file is not Makefile, otherwise it will just run that Makefile. And then you can also say like make a target name, which is what kind of target that you want to make, if the target is not included in the Makefile itself. So a sample Makefile, we will look at it. This is essentially like the main element in the Makefile is what is called a rule. The rule is simply target colon dependencies, and then you can also like use tab for any kind of commands to get the particular file. So here is an example. So the target is what is called my_prog, and then the dependencies are eval.o and main.o. So at the top level we define these two things. Now once these dependencies are satisfied, which command to run? So here we run the G++, which is the compiler, and then -o, which is the output, will be the myprog, and then the inputs are eval.o and main.o. Now we go hierarchically and describe each one of the dependencies. So for example, eval.o. The eval.o depends on eval.c and eval.h, which is essentially, you can think of this as the green.c and in the previous one basically, and then eval.h is the header file. And then how do we get to the eval.o? Basically we do a g++ minus compile and then eval.c. So this will generate the eval.o. Now let's look at the main.o. The main.o, again its components or the dependencies are main.c and eval.h. Eval.h, you notice that they are the same from both sides. And now the command to generate the main.o is g++, and then we say minus compile minus c, and then we do main.c. So we can also specify the comments using hashes that we already know basically. So the syntax is very similar to any other syntax, regular C programming syntax, you can say. So basically, like the -o is to specify the executable file name, whereas -c to compile only, no linking. So the -o does the compile and the linking of these two basically. So you can also make a Makefile with programming constructs such as variables, use of variables. So here the old way basically on the left hand side that you see essentially there we specify the top level target and then each dependencies, and then we go hierarchically and define dependencies. This is exactly the same as previously for the myprog. But if you want to use variables, then we can define the variable upfront as a header. So for example, C is defined as g++, objs or the object is eval.o and main.o, and then the headers are eval.h basically. So now simply we can say that my prog is eval.o main.o, that is the dependencies, but the command is essentially like $C, which is g++, and then the arguments are for the input is basically like $OBS, which is these two inputs. And then we also now go and do the same thing basically for eval.o, which is the subsequent target, and then the main.o. And then here we define basically like the one more additional one, which is the $objs, its target basically or its dependency is $header, which is the eval.h. And essentially, like I mean, so only like eval.h is present, then it starts working the way up. So this is convenient mainly because now if you want to replace the G++ compiler with a C compiler, then all you got to do is just change that thing. And in fact, you don't even have to change it inside the Makefile, but just define it like make C equal to CC, and then automatically like everything is replaced with CP, and they take precedence over the variables defined inside the Makefile. So fairly simple enough. And now there are some implicit rules essentially. The implicit rules are standard ways for making one type of file from another type. There are numerous rules for making a .o file from a .c file, from a .p file, etc. And make usually applies the very first rule that it needs. If you have not defined a rule for a given object file, make will apply an implicit rule for it. For example, our Makefile we specify basically like eval.o main.o, and then we say like I mean $C and so prog $objects and then $objects $headers. So here we omitted the eval.o and main.o targets. So it applies the implicit rule and then basically it creates it's equivalent of creating this rule where it's eval.o depends on eval.c, and then basically like it compiles that eval.c, and main.o is main.c, and then it compiles the main.c. So this is the way that the make understands this small makefile, which in this case it's okay, but make sure that if something that if you're not explicit about it, makefile will assume and then start this working its way. Now let's look at another way, basically, which is using the percentage. Percentage.o is percentage.c, and then this is a very succinct way of representing a rule, and essentially, like I mean, again here this is, it just replaces all these things with the appropriate stuff, and then works its way to do the make. So here you can see that once you specify that, and then basically like use the same thing. But at the same time, if you do an empty command, then it won't apply the implicit rule. So it's as good as specifying a rule and specifying an empty command. So just take care. If you don't want any rule to be applied, then you can specify it as an empty command, and that will the implicit rules will not get applied. So that's one way to override the implicit command. Now there are some variables you saw like in the previous one. We use a dollar less than. So those are what is called the automatic variables. The automatic variables are used to refer to the specific part of the rule components. So we know that basically like target dependencies, that's the general structure of the rule, and then followed by a tab and then the commands. Those are the mostly a shell command. So here you can say basically like if eval.o has eval.c and eval.h, and then g++ is the command, and then basically eval.c is the argument. So the dollar at will determine the name of the target of the rule. In this case it's eval.o, and then the dollar less than actually specifies the first dependency. In this one it is eval.c. So now if you go back and see, basically when we specify like dollar less than, there is the first dependency which is the percentage.c, which is anything.c. Now dollar caret is name of all the dependencies, which is in this case it's eval.c and eval.h, and then the dollar question mark names of all dependencies that are newer than the target. So in this case actually like I mean there is nothing in this one, so basically like there is nothing that gets defined for the dollar question mark. Now let's look at some of the make options. -f specifies the file name, which is if the make file itself, the name is not just the make file. So if you specify just the make file, then you don't need to specify the -f, otherwise you need to specify -f. And then -t is essentially using the command called touch to mark the targets as up to date. And then the -q is also known as question. Basically it looks for whether the targets are up to date, and if it is true then it exits with a 0. And -n is just the print the command to execute, but don't really execute them. So if you do like -n, like make -n of your make file, which is maybe like this, it will only like print all the various commands, basically like -t, which is like G++ minus O prog, and then it also says G++ minus eval dot c, and then G++ minus c main dot c, and then it linked it. So one thing is like so this is one way to actually just test out whether your dependencies are correct. Just do a -n. And then one thing to notice basically like -e, -q and -n cannot be used together, so only one of them should be present. And then -s is silent mode, that is it runs basically without echoing what it's actually running. And then -k is keep going basically, meaning compile all the prerequisites even if it's not able to link them. Now in order to make a flow work, you need to also specify some pony targets. The pony targets are targets that have no dependencies. They are used only as names for commands that you want to execute. So there are no dependencies basically. So these are basically kind of fillers, you can say. For example, there is one target called clean, which is just to remove all the files. So you can also specify in a long form, which is .pony is clean, and then clean is you can specify that clearly as the clean is a pony target. And then to invoke this, you can just say make clean, and then it will run that. So one thing to note is like I want to mention here, once you have this is your make file, you can only run subsections of make file. For example, you can say like make eval.o, and then it will only run this command, the eval.c, eval.h, and then g++ -c. Only it runs starting from the eval.o and then goes down. For example, it knows the targets basically the dependencies are eval.c and eval.h, and then it will run the g++ -c eval.c. For eval.h, it just looks for that file whether it is present, then it runs this command. But then it goes to the next main.o. Main.o is not a dependency. It's not a dependency for eval.o, so it won't run. It will stop there. Same thing you can run just main.o, and then it will run just that thing, and then it will stop. Only if you specify the target as my prod, then it will run everything. That too only if there is any change in the eval.o or main.o, then it will start running. Otherwise it will evaluate the dependencies. If the dependencies are okay basically, then it won't even run. So here similarly, like if you want to just invoke the target clean, we just say make clean, and then it basically removes all the things. And then the typical pony targets basically these are like to make all the top level targets. So we'll call it like pony all, and then all is all the targets basically are there. So if you do a make all, it runs basically everything and then see whether everything is okay. And then the other pony target is the clean, which deletes all the files that are normally created by make, and then print, which is print a listing of the source files that have changed. So now another thing is basically the vpath variable. This is a variable that defines directories to be searched if a file is not found in the current directory. And here you can specify a number of directories separated by columns. So for example, here vpath equal to dir colon, then go all the way. Basically, the first one is taken as the source, and then the second one is actually the path to that particular directory. So you can say like vpath dir colon dir, this is one of them, and then you can say like dir colon dir2, it's another one. So similarly, like with just space separated ones, you can specify as many as you want. And then if you want to specify like a directive like the lowercase path, that's a selective directory search where you specify a pattern and then what the directory is. For example, here vpath %h and then that is in headers directory. Now similar to vpath, there is also a gpath. If you want the targets to be stored in the same directory as their dependencies, you specify the gpath. Now there's also some variable modifiers out there essentially. The objects essentially, which is eval.o and main.o, and then we do a compile, and then you know that the dollar caret represents all the targets. So that's eval.o and main.o. Now the sources actually is essentially the same as the object. Only thing is we substitute the .o with .c. That's what the syntax means. So when we specify that here we can just say sources is eval.h basically, like where those are the source the targets essentially, and then the dependency is eval.h. And then we can also use conditionals to change the way that the makefile targets get executed. So we can specify specific things basically, and then the possible conditionals are if eq, if neq, if def, and if ndef, and all of them should be closed with an end if. And then the complex ones can be, you can use it as elif or else. So here is one example. So here we can specify basically like either it's a GCC or something else, some other compilation. And for GCC we can specify the libraries as -lgnu, whereas the normal libraries are defined as something else. So now if you say basically like if $cc GCC, that is if eq $cc is GCC, then libs is $libs for GCC, else its libs is equal to $normal libs and end it. So notice that actually there are no tabs at the beginning, these are basically just assignments. So it automatically, like I mean, now when you specify the particular target and basically like the dependency and then the actual command, based on what gets executed, it automatically replaces this one of them. So that's pretty much what I have on Makefiles. If you have any other thoughts to share, please do so with your TAs, and thanks a lot.